In this video, I want to show you how you can trace out a polar graph. So here in Desmos, I just have r equals 1 plus sine theta, and we have the whole graph. And sometimes it helps to see where the graph is starting when theta equals 0, and in Desmos, you can't, touch the points and see what their coordinates are. So one way to kind of see what's happening is to put a parameter or an interval on what your theta can be. So I'm going to start at 0. And I'm going to say I want to graph theta between 0 and a, right? And then we'll add a slider a. So a is going to act as our maximum value for theta. So here you can see it's at 1, and we have this little piece of the graph. Well, let's say I just want to go from 0 to 2 pi. So remember, a is going from 0 to 2 pi, which is the maximum value over here. Alright, so I can take this slider at 1, so this is 0, so we can see that when theta is 0, we're starting at 1. And 2 pi, looks like it's going to complete that circle. And of course you can hit this little play thing, which graphs it out, which is kind of fun. Then it goes backwards. You can modify this so it only goes one direction by hitting this thing. This only goes forward. And you can slow down the speed or speed it up if you want to. Alright, so I put another example up here. R equals 1 plus sine 2/3 theta. Now I've changed my maximum a value to 10 pi. So let's start tracing this and see what it looks like. This one's a little more complicated. So we might ask, oh, looks like right there it started retracing itself, right? We might ask, when does it start retracing itself? Looks like right around 19. 19 divided by 3 is pretty close to 6. I'm going to guess then probably 6 pi is when this starts repeating itself. There's to 6 pi right there. That looks pretty good. So this is just sort of a informal way to determine the minimum theta values you need to complete the graph. So another cool example. This is a crazy kind of a polar graph. Sine squared 2.4 theta, cosine to the fourth. I had to put the fourth out here. Desmos doesn't support any higher power of 2 in this kind of notation. So if you want cosine to the fourth, you got to put it outside these parentheses. And then again, we're letting theta go between 0 and a. And I've set my a up here to 20 pi. So it's kind of fun. Let's draw this and see what it looks like. Well, I got to slow that down. That's too fast. That's too exciting. We got to... Let's slow that down. Speed. Let's try that. That's better. It's going to start repeating itself. Look like right there it did. Somewhere around, right around there, 32. 32 divided by 3 is around 10 something. I'm going to guess that's probably 10 pi is going to complete that before it starts repeating itself again. That's kind of a cool one. It's interesting with this graph, if you just change it to cosine to the third. Wait, let me move this back so it's a surprise. It's fun to just play around with these. Change the things you're multiplying theta by, change the exponents. Alright, let's try this one. I actually haven't, oh, that's exciting. I haven't done this one completely out yet. We might need more than 10 pi. Let's see if we do. All we did was change that exponent on the cosine. It's kind of making the same sort of graph around the outside. Oh, I think we're going to need more than 10 pi. Alright, I only want this going forward too. I don't want it to go backwards and undo itself. So let's go out to 20 pi. Now I put my step at pi over 100 just because I want it to be smooth. If you make your step too big, pi over 100 is pretty small. Oh, see, it's done. I guess it was done around 10 pi. Thought it was gonna. So that's pretty cool, right? I just like watching it draw. I mean, if you took all this A stuff out, you would just get this picture. Feels like it would fill in more, but I don't think it does. It's all repeating itself. Alright, that's a fun one. Alright, so I hope this helps a little bit with visualizing polar equations and using this to watch it get drawn. It's kind of fun to do that.